Hi guys, and welcome back. Let's go ahead and set up our namespace here along with a deployment controller so that we can set our pod replicas here. And then the other thing we'll do is create a cluster IP service. And I'm not going to use a load balancer service and actually expose it to the outside world, because in order to test out this application's scaling with the horizontal pod autoscaler, what I'm actually going to do is spin up a pod directly inside of the same namespace here and give it a cluster IP as well. It automatically gets one, but this pod here is going to act as the client. And then this client will basically just hit the service on its cluster IP rather than having to go out of the cluster and then hit a load balancer and go through that additional process. So it's just a little bit easier to test things out privately by running an interactive pod as a client here that's just getting a cluster IP and then exposing the service purely on a cluster IP without having to involve the additional load balancer resource that it typically creates. So for starters, we need to go ahead and create a deployment controller. So I'm going to go ahead and just copy an example from the documentation that is right over here, and we'll tweak a couple of things about it. So I'm under the tasks, run applications, and then horizontal pod autoscaler walkthrough. And I'm just going to grab the deployment controller from here for now and come back to my terminal. And then we're going to go ahead and just create a new file. Let me create a directory here under my Git directory, and I'll just do make-dir HPA, go into that directory, and then we'll just do vim and say deployment.yaml. And then I'll do I for insert, and then we'll go ahead and paste this in. Of course, let me do :set paste mode, and then try that one more time here. All right, that looks much better. So we are going to, of course, leave the API version and the kind the same, because this is going to be a deployment resource in our cluster. For the metadata here, we could give our deployment controller a name. So I'll say Nginx website, for example. That's just going to be the name of the deployment controller itself. And then down here for our labels, so under the selector match labels, and then for the labels for the actual pods, under the pod spec or pod template down here, what we can do is just change this and say app name is, let's say biz website. And then we'll say under labels here, because these need to match, we'll say app name, and then set that to biz website as well. And now we can specify a container image that we would like to use to run our application. So I'm going to change the container name here to just Nginx. And then instead of using this HPA example, I'm just going to use a basic Nginx container image directly from Docker Hub. And so if you go out to hub.docker.com, you'll see that they have an official Nginx repository out there. So I'm just going to be using that as a sample. And that does listen on port 80 here. And then for resources here, I'm actually going to, I think I can lift to the limits here. So I'm going to go ahead and just maybe comment these out. So let's do a comment here on both of those lines. And then for requests, we'll just say it requests, let's say 100 millishares of CPU for this particular pod. Or actually, let's bump it down to, let's say, 50 maybe. All right, so I'm going to hit escape, and we'll do a :wq to save that. And then I'm going to create a namespace for us to work inside of, kind of like what you saw here. We're going to create a website namespace, and then we'll create our deployment controller inside of that namespace. So I'll do a kubectl, create namespace, and we'll just call it website. And then I'll go ahead and do a kubectx. If you don't have kubectx, or actually kubeNS installed, go ahead and get that installed. It's a nice handy utility where we can just kind of change the default active namespace that we want to use. And then I'll do a kubectl apply -- file name, and then we'll do deployment.yaml. So that should create our deployment controller. And actually I'm going to check really quick here to make sure it has a single replica. Yep, so replicas is currently set to 1. If we do a kubectl and then get all from our current namespace, which again is website right up here, then that should return to us the deployment controller, the replica set that the deployment controller created, as well as a single pod. So at this point, if we wanted to manually scale this, we could just do a kubectl edit and deploy /nginx website. And then we could simply change the replicas here. Looks like it opened up in Notepad here. So we could just change the replicas to, let's say, 2, for example, and then save that, and then close Notepad. And then if we just do a get all again, you should see that it scales up to 2 pretty quickly. And that's how we can basically just do a manual scaling of our deployment controller. But we, of course, want to auto scale it. So I'm actually going to edit this and just bump it back down to a single replica and let that scale back down. All right, so now that we've got this created, we need to create a service controller with the cluster IP so that we can route traffic to these different pods. And if you recall, we gave these pods a label in the deployment template called app name, and then the app name should be biz website, I believe. And we can confirm that just by doing a kubectl scribe and just grab one of these pods right here. And that should show us what the labels are that we put on here. So let's look for labels, and then it's app name equals biz website. So now let's create that service controller. I'm going to do a kubectl create service, and we're going to use the service type of cluster IP instead of load balancer. We'll do cluster IP, and then we need to give the service a name. Let's call it biz website SVC. And then we also need to specify the TCP ports, and that would be, let's say, port 80 forwards to port 80. So port 80 on the load balancer's IP, or I should say the service controller's IP, will forward to the pods that are backing that service on port 80. And then once we've created the service, we need to configure the service selectors to point to any pods that have these labels right up here. I'm going to do a kubectl, and then we'll do set, and then we're going to set selector. So say set selector, and then we need to set the selector pair. So that would be app name equals biz website, just like our pod has. And then, of course, we need to specify the resource that we are affecting, and that's going to be service slash, what do we call it, biz website SVC, I think. And so that should update it. And it doesn't have a resource named that, so I think maybe I got these reversed. Let's do set selector. There we go. So now we basically need to make sure that we put the service resource first and then the label after it for the selector. So now if we do a kubectl describe on our service here, we should see that it registered a single endpoint. Sure enough, that is our Nginx pod. And so basically our service controller has a cluster IP of 10.100.12.124. So if we were to get a pod inside of our cluster and hit that IP on port 80, that should forward to our pod, our Nginx pod on port 80 as well. So let's just test that out really quick. I'll do a kubectl run, standard in, pty, -- equals, let's say, Ubuntu, and then I'll just give it a name like Ubuntu client for now. Of course, I misspelled that, but that doesn't matter. It's just the name of the pod on our server, so that name doesn't really matter. But then we should get an interactive prompt here. So now I've got a pod, I've got this client pod sitting next to the service, and the service is forwarding traffic to a pod based on the labels, the label selector. So if I do something like apt update and apt install, let's install the HTTP IE utility, which is just a Python-based HTTP client utility that we can use to test things out. We should be able to do HTTP on the service name, which is biz website SVC. All right, so once that utility is installed, we'll do HTTP. That's the binary name that we call. And then the URI that we want to call is just HTTP biz website SVC. And that's just the name that we gave to the service controller. And that should resolve inside the cluster thanks to core DNS. And as you can see, our service controller is working correctly, and it's forwarding traffic to the one and only pod that's running inside of our cluster here. All right, so we're about at the point where now that we have the deployment controller and the service controller created, we can go ahead and set up our horizontal pod autoscaler. I hope this has been informative for you, and I'd like to thank you for viewing.